Welcome to Understand the Math. In this problem, we're going to use Gauss-Jordan elimination to find the inverse of this matrix, if it exists. To do this problem, we're going to take our matrix A and we're going to augment it with the identity matrix. Then we're going to put these matrices in reduced echelon form. And what's going to happen is if our inverse exists, our A is going to reduce to our identity, and our identity is going to reduce to A inverse, which is going to be our answer. Hang with me. These problems are a little bit long, but it's really good to go through these in detail. The best thing that you can do when solving these problems is to just, as you go through every step, glance back and just make sure that you've done it right. So we're going to begin and we're going to put our matrix A on the left. And then we're going to put our identity matrix on the right. And our identity matrix is the same size as our regular matrix, A, but it just has 1 along the diagonal and the other entries are 0. What we're going to do to start is we're going to switch rows 1 and row 2. And the reason that we're going to do that is row 2 has a 1 as a pivot, and that's really good to be able to start with a 1 as a pivot if we can possibly do that. I'm going to write down our row operation. We're going to have row 1, and we're going to interchange it with row 2. The important thing with this is whatever you do on the left, you also do on the right. So we're going to interchange our rows on the right as well. Now we're ready to start. Let's go ahead and let's circle our pivot. And we're going to begin by getting a 0 below that pivot. So the row operation that we're going to use is we're going to take row 2 and we're going to replace it with row 2 minus 2 times row 1. This is going to give us this matrix. So row 1 is going to stay the same. Now we're going to change row 2. So we're going to multiply row 1 by -2 and add it to row 2. So we're going to pick up a 0. We have a -4 plus 1 gives us a -3. And then we have a -2. This stays a 1. And then we have a 1 times -2 gives us a -2. And then we have a 0. And then our third row just stays the same. Now let's go ahead and let's look at this matrix, and you might want to think what you would do. Notice that this pivot is a 1. So I think the best thing that we can do, so we don't introduce fractions before we have to, is let's take row 2 and let's interchange it with row 3. Our row 1 stays the same. And now we're going to interchange rows 2 and row 3. So row 3 comes up here to row 2. And row 2 goes down to row 3. Now let's go ahead and let's circle our pivot. And we're going to get a 0 below that pivot. So our row operation is we're going to have row 3, and we're going to replace it with row 3 plus 3 times row 2. There's a lot of writing with these problems. Okay, so our first 2 rows are the same, so we just got to recopy those. Now we're going to change our third row. We're going to multiply our second row by 3 and add it to our third row. So we have a 0, 0. We have a 6 minus 2 gives us a 4. And then we have a 1 minus 2, and then this next entry is going to change. We have a 1 that we're going to multiply by a 3, add it to 0, gives us a 3. Okay, we've done really good. Now we're going to start the backward phase of our algorithm. And what's going to happen with this phase is we're going to circle our pivot, and we're going to have to make our pivot be equal to 1. So what we're going to do is we're going to take row 3, and we're going to replace it with row 3 divided by 4. And we can no longer avoid fractions. So we're going to get fractions with this, but that's okay. Here we go. Now, when we do the backward phase of the algorithm, it's common to write the last row first. I know that's a little awkward at first, but you'll get used to this. So we're dividing this row by 4. So we pick up a 1/4, a minus 2 over 4, and a 3 over 4. So I know a lot of students hate fractions, and if you're one of those, that's okay. Just hang with me, we'll get through this. Now let's go ahead and let's circle our pivot. And I'm going to use a blue highlighter this time so that you can see that we're doing the backward phase of our algorithm. And we have to make those entries a 0. I'm going to now write down our row operations. Row 2 is going to become row 2 minus 2 times row 3. And then row 1 is going to become row 1 minus row 3. It's really good to be able to do a couple of row operations at a time when you're doing these types of problems. Our third row is going to stay the same, so let's go ahead and let's write that down. Make sure to recopy things carefully. Students will often make a mistake just by recopying. Now we're going to change row 2. Row 2 is going to become row 2 minus 2 times row 3. So on the left-hand side, we're going to have a 0, 1, and then we're going to have a minus 2 plus 2 gives us a 0. And then on the right-hand side, we're going to have a minus 2 times 1/4 gives us a minus 2 over 4. And then we're going to have a minus 2 times a minus 2 over 4. So let's write this down. Minus 2 times minus 2 over 4. That's actually going to give us a 1. Never hesitate to write things down with fractions. And then we're going to have a 3/4. And we're going to multiply that by minus 2. And we're going to add it to 1. So let's see. This is minus 6 over 4 plus 1. That's minus 2 over 4. So we'll go ahead and we'll plug this in up here as minus 2 over 4. Okay, let's go ahead and let's change the top row. We're going to take row 1 and we're going to subtract row 3. So this is going to become a 1, 2, 0. And then we're going to subtract row 3 from row 1. So this becomes a minus 1/4. And then we're going to have a 1 minus a negative 2 over 4. So this is going to be a 1 plus 2 over 4. So let's write this as 6 over 4. And then we're going to have a 3/4. We're going to multiply it by negative 1 and add it. So this becomes a minus 3/4. Okay, hang with me. We are almost done. Let's go ahead and let's circle our pivot. And then I'm going to highlight the number up here that has to change and go to 0. That's that one right there. So to do that, let's see what row operation we need to do. We're going to take row 1 and we're going to replace it with row 1 minus 2 times row 2. And I think this one's going to be a little bit complicated. So what I'm going to do is I'm going to put a minus 2 here and I'm going to highlight this row because that's the row that we're going to multiply by minus 2 and add it to the top row. Our bottom row is the same, so we're going to recopy that and make sure and be careful so you recopy it correctly. And then we have our middle row. Now we have to do some work. Our top row becomes a 1, 0, 0. And then we're multiplying what I highlighted in pink by negative 2, and we're adding it to our top row. So we might have to do some calculations down here. Let's see. So we're going to have a minus 2 times a minus 2 over 4 minus 1/4. So let's see, what is this? This is a 4 over 4 minus 1/4. So that's going to give us a 3 over 4. Let me give us a little bit more space here. Now we're going to take a negative 2 times a 1. And then we're going to add 6 over 4. This is going to be equal to a minus 8 over 4 plus 6 over 4. That gives us a minus 2 over 4. We'll go ahead and put that in up here. And then we have one more to go. Let's see. We're going to take a minus 2 over 4, and we're going to multiply it by a negative 2, and then we're going to subtract 3 over 4. So this actually gives us a 4 over 4, which is 1, minus 3/4, which is 1/4. And we'll put that right up here. Okay, so we're almost done. That's our A inverse. So we're going to write it down here. So we're going to say our A inverse is our matrix 3/4. And we'll go ahead and simplify fractions. So we have a minus 1/2. And then we have a 1/4. And then a minus 1/2 again, a 1, and a minus 1/2. And then on our last row, we have a 1/4, a minus 1/2, and a 3/2. I always tell my students that's one of the longest linear algebra problems that you're going to do. The nice thing about this is that there is a good built-in check. What you can do to check your answer is you can take matrix A, multiply it by the inverse that you just got, and then you can make sure that it equals the identity.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.